isometric and orthographic drawings is what we're going to talk about right now. An isometric drawing, okay, so we're talking about two different types. The isometric has to be done on, that's not a pen, on this kind of paper. It's called isometric dot paper. Actually, I'm going to hand you some right now. Okay, so isometric drawings. There is a picture over here, right? This guy right here is an isometric version of a drawing that we're going to put onto the isometric dot paper. Now, if this is horrible for you, I don't ever put a question like this where you have to put it onto dot paper on a quiz or a test. Really, what I want you to grasp more strongly is this stuff, the orthographic. So you will have to do orthographic drawings for me on a quiz or a test, but this just kind of helps you get there to like understand what's going on in the picture. So this is more of a like, let me prep you for what's coming next. So here's what we're gonna do. I typically say it's probably easiest to put this on dot paper if you start at the top and work your way down, or if you start at the front and work your way back. That makes the most sense to me. If something works better for you, do it that way, okay? There's not like a right way for this. It's kind of a beautiful thing. What I would do is this. I would start, and I'm gonna color code each box here just so you can see where I'm at. I would start up there with that diamond, okay? One thing to note, you will never, ever, it does not happen, you will not draw a horizontal line. You'll draw plenty of vertical lines. You will never draw a horizontal line in isometric drawings, okay? So I'm gonna draw way up here a diamond like that. Okay, so that's this diamond that we just outlined. And then from there, if you look what's happening, from these 3 points, we went straight down, straight down, straight down, straight down. So we're gonna go down, 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 okay? And then we're gonna finish off that box. Finish it here and here. Okay, so you should have 1 cube on your dot paper right now, or in your notes on that dot paper right now. Then if we jump over to the right side, we have another diamond. Okay, that's my blue box here. Okay, that diamond comes off of this line right here. So I'm gonna make my diamond. Notice I'm not drawing horizontals, right? Everything's on a slant, unless we're going vertical. So that's my next diamond. And now we're gonna work down from there. So 1, 2, 3 down is 1, 2, 3 down. And then we're gonna finish off the bottom. Finish off that cube. Okay, last one is the green guy. So we're gonna draw that diamond again. That's gonna be right here. And then go down from there. One of those downs has already been drawn in. Okay, and then finish off the bottom. Isn't that cute? So fun, right? Question for you. How many cubes are there?
4.
There's 4, right? You're not seeing one of them. You drew 3, but that red or orange cube is elevated, right? So it's not just floating there, there's something below it. So sometimes things will be kind of hidden that you're not seeing, but it is there, okay? Okay, any questions on that? And like I said, I don't make you do a lot of that, but if you want to play around with it on the dot paper or whatever, that's great. You'll do a couple in the homework just to get comfortable with it. Where we're going to spend most of our time is this, the orthographic, okay? So with these orthographic drawings, what happens is you take this picture on dot paper and you look at it from 3 different perspectives. And those perspectives, and I'm going to color code this too, just so you can see which is which. You have a top view, you have a front view, and you have a right view. Okay, so top, front, and right. This stuff does not happen on the dot paper. Did you hear that? Don't do an orthographic on dot paper. You have the dot paper right here, right? They give it to you on dot paper. You're taking it off the dot paper and making it two-dimensional. You're making 3 flat images. So what happens is you'll say, what is my top view gonna look like? What is my front view gonna look like? And what is my right view gonna look like? Okay. Now the top view is probably the one that gets done wrong the most, and I'll tell you why. Usually people see this and they try to make the top view come from here, from what would be like the front of our picture, right? But they told us the front is over here. So we need to come from the front and then look down. So think of yourself in a helicopter, right? You hop in a helicopter and you go, I want to see what my school looks like from above. So you fly up to Valley Christian from the front. Okay, we'll call the high school office the front. So you fly up from the front and then you look down on it. What would you see? You're not going to see dimension, right? You're going to see the outline, the shape that it is. So what we're going to do is we're going to say, well, what would this top view be if I come from the front? Okay, the first thing I would see is this box on top. So we're just going to draw one square. Okay, and technically that's the bottom of our top view. Okay, then if you keep going, this 3 boxes are all on the same level. So we're not going to separate those boxes at all. They're all going to be one piece. Okay, if they're the same dimension, the same depth, we keep them all one piece. So it's 3 boxes. It goes 2 back from this front one, right? From this front one, you have 1, 2 directly behind it. So we're going to go 2 back. And you don't need to measure these. You just eyeball it is fine. Okay. Then it comes back down 1 and moves over to the right one. So my top view looks something like this. Does that make sense? So change in depth, you draw a line in. If there's no change in depth, don't separate the boxes. Okay, that's the top view. The front view, if you think about, if I were to smush this set of blocks flat, what would I be seeing if I looked from the front? Well, I would see this, which is how many blocks tall?
2, 3.
That's 3, right? If I were to draw the lines in, there's 1, 2, 3 blocks, right? So 3 blocks tall. And then next to it, from the front, I would also see that block. So it's going to be 3 blocks tall, but not separated. And then 1 to the right, because that one is set back further. We do draw the line in. Does that make sense? So that's your front perspective. And then your right side, you would have 3 blocks tall on the left of the right, if that makes sense. Okay, so 3 blocks tall there. And then where's this one going to go? To the right of it, level with that bottom story, right? That's on the same level as this guy right here. So we're going to go 1 block to the right. And then do you have anything else? 1 more block, right? There's 1 more block to the right of that. It's hard to see it because it's just a part of a block in the picture, but there is a block there. It would look like that. Any questions on that? Do you like that? Or am I just a big math nerd? I love it.
So on the right perspective, so I understand that in the right view, there's a block and then a block. But on the right view, you're looking at it from like that angle. Why is there, it goes 1 block and then another? Why is that?
Thank you. Because you're thinking of it flesh, right? We're not using depth anymore.
Oh.
So if we were to flatten that whole thing, here's what we would see.
Oh, I see.
Yeah.
I was confused because I thought it was depth. Never mind.
Yeah. Okay, here's what I want you to do. I want you to try this one on your own. So give me those 3 views again. Give me the top view, the front view, and you don't have to color code these, you guys. You can do everything in one color if you want. I just color code for those that it might help to see a little distinction, okay? So top, front, and right view, give that a go yourselves. So for the top view, how many different shapes did you draw? 3, right? You should have drawn a square, and a rectangle. Did you get that? Okay, so your top view, remember coming from the front, we would see this square. And then directly behind it, so above it in the picture, is another square. And then to the right of that is 2. So that one's going to be a rectangle. Okay, so that's your top view. Did you get that? Yeah. Your front view, okay, we would come the front here. I would start with this one. So you have one box right there. And then this next piece is all one piece, which is a little bit of a pain. But if you wanted to draw all the lines in and then just erase, you can do that too. I just think it's easier just to go for it. So you would go 2 stories above, so up 2. You got to go over and down, right? And then this thing is a 2 by 2 block. So we need to go 2 to the right and 2 down and then back to where we started. So that should be your front view, relatively speaking. My dimensions aren't perfect. Questions on that? Yes, ma'am.
With the box, like, you know how the like, little box is inside the kind of like L shape, but it be on the outside, or does it have to be like in it?
Are you talking about this box?
Yeah.
It has to be inside that. It has to line up with this top one.
Okay.
Is that what you're saying?
Yeah.
Yeah. Yep. It's got to be, because you're thinking, you know how they like smash a car flat? That's kind of what we're doing. We're taking a big machine and we're just going smash it flat. What would I see? So when you smash it flat, this would rest right here in the figure. Okay. Okay. Last one, the right side. You have one square on the left of the right side. Okay. Where does this go?
Right next to it.
To the right of it, 2 stories tall, right? So to the right of it, 2 blocks high. And then where does this one go?
On top of that.
On top of that, right? Right above it. So if we smushed it flat, it would be right here. Okay? Questions on that? Yes, ma'am.
For the one before it, the
Yeah.
front view.
Uh-huh.
So instead of drawing
Oh.
a little square or cube inside of it, I drew an L, like on top, and then I just came down.
Next batch here. This one is not as fun, quite frankly. Mostly just because it's all the terms you need to know to be able to do all the geometry that you're going to do this year. So I apologize in advance for a bunch of definitions. The good news is I wrote them all out for you, so you don't have to write the definitions. The definitions are there. You're just going to draw a picture of what those definitions mean so that you know what it is when you're doing it in the homework, okay? So my apologies. I know definitions are not fun, but, well, maybe they are for you. They're not fun for me. I'd rather do the actual stuff. Okay, 1.2a. We are going to talk about geometry terms, starting with a point, okay? And I'm sure you've all heard of a point before. You've seen plenty of points in your life, but the definition, which is not actually technically definable, is a location, okay? It's a place, essentially. A point is holding a location. It has no size. There's not like a big point and a little point. It's a point. It's just a location somewhere. The way we write it is we put a dot and then we put a capital letter behind it. So A, B, C, there's lots of different letters we will use. The way we say that is point A. Okay, so whenever I do the quotation marks, I'm just saying this is how you would say it. So that is point A. A line is just basically a whole slew of points so close together that it doesn't look like a bunch of points, but a line goes on forever, okay? So when you see arrows, there's no end to it. So a line is gonna look something like this, And in reality, what this is it's just a whole lot of points so close together that you can't see any gap. Okay, that is a line. It goes on forever. It has no end. How we name it will be something like this. So to name a line, you're going to use two letters. Let's say this is X and Y. Okay. Are those the only 2 points on that line? No, there are a slew of points on that line, right? We name it with those two letters and the line over top. Okay, so you would say that line XY. Okay, now if you flipped that around, you could also call it line YX. It's the exact same line. Okay, so when I ask you to name a line, you don't have to name it both ways. Pick one, XY or YX. Typically in math, we just go in alphabetical order or we go from left to right. The other option is sometimes they'll just put a little like cursive L on the side, and then you could call that line L. Sebastian.
Every single line we see in geometry has those arrows.
Every line has the arrows, yes. I'll tell you about a segment in a little bit, and then that won't. But a line will always have the arrows over top, yeah. Any other questions about a line? Okay, next one is a plane. And a plane we usually draw as a parallelogram, so something like this. Basically what it is, it has no thickness. So I try to represent it with a paper, but a paper is even too thick, right? A plane is something like this that just keeps going in every direction. The floor, right? Think of the floor as a plane. Think of the wall as a plane. It just keeps going though forever and ever. The floor stops, the walls stop. They don't in a plane. It just keeps going, all right? So for a plane, we typically have two ways, there's multiple ways, two main ways to name a plane, okay? Sometimes they will give you a letter, but it won't have a point in front of it, okay? We could call this plane P, if it's just a letter up in the corner somewhere. Other times, they're going to give you points. So they're going to say, this is A, and this is B, and this is C, and this is D. Okay? Notice those all have points in front of them. So if you're going to use points, you have to use 3 or more letters to name it. Okay? And those 3 letters cannot be in a straight line. And we'll talk more about that later. But 3 or more letters. So I could call this plain ABC. Okay, or I could call it plain ABCD. As long as all of the letters I use are not in a straight line, I can name the plane that way. Now, technically, I could name it DBC as well. It doesn't have to be in alphabetical order, but you need at least 3 points. Okay, if you only named 2 points, think about that. If I said, here's my plane, right? And here's a point, and here's a point. Well, I can put another plane through those 2 points this way. So that's not telling me this plane. It's telling me a whole bunch of planes if I only use 2 points. So you have to use 3 that are not in a straight line, okay? Okay, that is planes. Then we have collinear, and you can kind of see it in the word co and line, right? Collinear points are just points that lie on the same line. So if I have a line like this, right? These 3 points are collinear. Okay, they're on the same line. Whereas if I had this instead, say this is point X, point Y, and point Z, we would say these are non-collinear. If they're not in a straight line, they are non-collinear. How's my speed? Am I going too fast for anyone? We're okay? Okay. So that's collinear. So what do you suppose coplanar is going to look like? I mean, it says it right there. They're going to lie on the same plane, right? It's points that lie on the same plane. So coplanar points typically will look something like this, okay? Coplanar can be a little bit tricky because people expect it to be on the plane that they're seeing. But if I were to put a point down here, T, okay? Technically right now, G, I, and T are coplanar. Let me show you why. Let's say this is the plane GIH, right? This is the pink parallelogram that I drew there, right? On it, there's G, there's I, and then down here is T. Do you see a plane that could go through all three of those?
No. Oh.
There is. 2 points here and a point down here. I can cut through that like this, right? If I kept going, I'd hit all three of those points. So just because they're not on the plane that is drawn doesn't mean they're not coplanar. So be careful with that. Pay attention to if there's any 3 points, which you'll learn more about this tomorrow. Yes, tomorrow. So don't stress about it right now. I'm just trying to get the thought going in your brain. But that is a thing. So if I were to say non-coplanar, okay, that has to be 4 or more points because any 3 points will be on the same plane, which again, you'll learn about that tomorrow. But I could say right now that point G, point H, point I, and point T are non-coplanar. There is no one plane that I can put through those 3 points and this point down here, right? So that's non-coplanar. We'll talk about that more.
You said no plane would be able to go through the non-coplanar right there because they're on the line? I mean, they're like...
So you have G, I, H are all on this plane, right? But they're spread out. They're not in a straight line.
Mm-hmm.
So then to try to get this plane that's going this way to go through this is impossible. But if I ditch one of those, if I just do G and I and T down here, then I can go through that this way, right? So it's tricky. We'll talk about it a lot more tomorrow.
Basically like switching it like this.
Mm-hmm. Yep, turning the plane a different way. Yep. It's a totally different plane, right? It's not that pink rectangle or parallelogram anymore. Okay, so example 1 here. Can you tell me 2 other ways to name line QT? So right now, line QT, that's this line, right? Can you give me 2 other ways to name that line? Okay, so you could just change the order, right? You could say line TQ, and then it's the exact same line. But you could also just use different letters, because remember, lines keep going forever. So I could call it line QN, and it's all the same points as line QT, right? Or I could call it line NT, and same thing. It's still all the same points. I'm just naming it a different way. Does that make sense? Hopefully. Okay.
Anything?
You say that again?
You can name it anything?
You can name it any 2 letters using the points that are on that line. So line N, line NQ, line QN, line NT, line TN. So any of the 3 points, use 2 of the 3, and you're good. The other way you could name this, because there's this little M down here that's not a point, is you could call it line M also. Okay. Okay, plane P. Notice, P does not have what? A point, right? There's no point in front of P, so it is not a point. It's a name. It's naming that plane, plane P, okay? If I want to name plane P a different way, I have to use how many letters?
3.
3 or more, okay? So give me another name for that plane.
Just any letters?
Potentially. Anyone think they can name that plane for me? Remind me of your name.
David.
David.
VQR.
VQR, yes, plain VQR. Now look what David did. He did not give me RQS. Why?
Because those are in line.
They're in a line, right? We can't do a line because if we do a line, there's a plane that cuts through my arm this way, right? Horizontally, but there's also a plane that cuts through my arm this way. So you haven't specified which plane you're talking about if they're in a line. So don't put them in a line, okay? Keep it triangular somehow. So plain VQR would work. What's another one that would work? RSV, yes. Okay, any questions on that? Okay, was that a question? Okay, tell me, I'm gonna get all this junk out of here. Can you tell me 3 collinear points? RQS, point R, point Q, and point S are collinear, right? 3 points on the same line. Can you give me another set of collinear points?
T, Q, and N.
T, Q, and N. Point T, point Q, and point N. So if they go in a straight line, they are collinear. Okay? Okay, 4 coplanar points. R, S, V, and Q. Point R, point Q, point S, point V. Okay? Now, technically, there's another option. There's several other options, which is not going to look evident to you necessarily. But if I picked point N, point Q, and point T, right? My plane is cutting through those 3. I could go through R, which is over here, and my plane is going to go through all of that, right? So technically, you could say N, Q, T, and R are also coplanar. They're not the plane you see. They're an invisible plane that's not drawn in right now, but there is a plane that goes through that, okay? Again, we'll talk more about that tomorrow, so don't stress if you don't see it right now, but I just want to keep you thinking about it. Any questions about any of those before we move on? Okay, almost there. Space is the set of all the points in the 3-dimensional world. So whenever we're talking 3-dimensional, they're going to talk about space. When they're talking 2-dimensional, they're going to talk about a plane, okay? A segment is just a part of a line. So let's say we have a line here, okay? If we named this as a line, it would be line CD, right? This is not the segment, okay? That's line CD. If I want the segment CD, that is talking about this. It has endpoints, okay? We would call it segment CD, and the way we show it is with just a bar over top without the arrows. So this is segment CD, okay? The line is the whole thing. The segment is the piece, okay? I could also call it segment what? DC, just flip it around. Good. Okay, array is different than that. Array kind of takes a line and a segment and combines them. So you will have an endpoint on one side and a line, an arrow on the other. So if I have this, for instance, and this is AB, okay? Rays you cannot switch like we can with the segments and the lines. Array has to start by naming it from the endpoint. So we're going to start at A and go through B. Okay, we say that ray AB. Okay, if I went this way instead, and this was C, so I started here and I went this way, you always start with the endpoint. So it's going to be backwards here. It's going to be ray AC, and the arrow will always point to the right. Okay, so ray AC would be if I started at A and went through C. Okay, and what I just drew for you there are opposite rays. So ray AC, ooh, and ray AB are opposite rays. Okay, opposite rays have to share an endpoint. Okay, that's the key component here. They have to share that letter A, for instance. So if they share an endpoint but go opposite of each other, they're considered opposite rays. There can't be any other overlap than that one point. Okay? Okay, home stretch. This is it, example 2. We're gonna name all the segments. So what is every segment you see here? And you don't need to name the same segments both ways. Give me one name for each segment. Give me one segment. DE. Okay, so this is segment DE. You do not need to say DE and ED. Okay, pick one. I don't care which one, just pick one. So that's one of them. What's another segment?
EF.
EF, good. That would be this one, right? Do you see any other segments? DF, the whole thing, from here to here, right? That is segment DF, okay? Or FD, which is fine also, okay? Okay, then we're gonna name the rays here. Give me a ray. ED. Okay, so ED would be starting at E, going through D. All right, can you give me another ray? EF would be starting at E, going through F. Those are actually opposite rays that we just named, right? You see any other rays? DF. Okay, so DF starts at D and goes through F. Okay, trick question. What about DE? DE is a ray, but it's the same ray as DF, right? So you do not need to name DE and DF because they both look like that. DE, because the arrow keeps it going. DF, that arrow keeps it going. So they are the exact same points represented. Okay, so just pick one of those. So then what's the last one? FE or FD? Yep, the one that goes this way, right? So FE or FD, either one of those is fine. Sebastian.
Would you get marked on the test if you put DE in DF? Would you take a point?
If I asked you to give me 2, and those were the 2 you gave me, yes, because those are the same one. If I asked you to give me 2 and you gave me both of those and a different one, then I'd probably give it to you.
Okay.
Yeah. Okay, what are the opposite rays? What is it? ED and EF, yeah. ED and EF. Right? Starting at E, going to the left, starting at E, going to the right. Are EF and FE opposite rays? So EF is here, FE is here. They don't have the same endpoint, right? The answer is no. They have different endpoints and they have overlap. You cannot overlap. Oop. Okay. You made it. We don't have quite the half hour that my other class did. But you do have 20 minutes. So if you need a break and you need to just like catch your breath for a minute, that's fine. But then get going on, you have 1.1b is due tomorrow and 1.2a is due tomorrow, okay? If you want to take a PDF of that isometric dot paper and drop it into a notability document, that's fine. If you want to do the homework on that dot paper and then scan that dot paper, that's fine. Just make sure you get all of those problems in.